Today we're going to learn how to graph quadratic functions, or parabolas, in vertex and intercept form. Now last time we learned how to do this in standard form, but these will actually be easier because we'll have some information to start with. So your essential question is, how do I graph quadratic functions in vertex or intercept form? So first we're going to start with vertex form. And this is an example of what vertex forms look like. It's y equals a times x minus h squared plus k. Now, a, h, and k are all going to be numbers that change, and they each tell us something about our parabola. So the vertex is the point hk. Now you'll notice that in the formula there is a minus sign here. So whatever h is, it's actually opposite of that number. So if this was a 2, then the point would be 2 and then whatever k is. So it's opposite of what you would think. Now, x equals h, whatever h is the line that is the axis of symmetry. That's the middle of your parabola. And if a is positive, if the number in front is positive, then the graph opens up. And if a is negative, then the parabola opens down. So we're just going to practice graphing an equation in vertex form. So we're going to graph y equals negative 1/4 times x plus 2 squared plus 5. So first we need to plot the vertex. Now the vertex is going to be hk, and remember whatever h is going to be opposite of what you think. So since this says plus 2, it's actually a negative 2. So the vertex is the point negative 2, 5. So we're going to plot that first on a graph. Okay, then obviously because the vertex is at the point negative 2, 5, then the axis of symmetry is going to be the vertical line x equals negative 2. Because it has to go through the vertex. Okay, then we just have to plug in two numbers that are close to the axis of symmetry. And you only have to plug in two numbers either on the right side of the vertex or two numbers on the left side of the vertex, because a parabola is symmetrical, so you can just graph 2 points on one side and then reflect them over the axis of symmetry and graph them on the other side. So also, because there's a fraction here, because we have negative 1/4, we probably want to plug in multiples of 2 or 4 or even numbers so that this will come out to be even. Now, I would plug in multiples of 4, but if you do that, you might get large numbers. So we're going to plug in the next two numbers on the side of negative 2, 5. So that would be 0 and 2 if we plug in the next two even numbers. So if I plug in 0, then I have negative 1/4 times 0 plus 2 squared plus 5. So 0 plus 2 would be 2. 2 squared would be 4. Negative 1/4 times 4 would be negative 1 plus 5, which equals 4. So we're graphing the point 0, 4. Okay, then I'm also going to plug in 2 for x. So if I have negative 1/4 times 2 plus 2 squared plus 5, and 2 plus 2 is 4. 4 squared is 16. Negative 1/4 times 16 would be negative 4 plus 5, which would equal 1. So we would have the point 2, 1. Now you can use a calculator to do all of this, or you can do it in your head, whatever you'd like. Now we're going to go ahead and graph these so you can see what this would look like. So we got our points 0, 4, and 2, 1. We also have our axis of symmetry. So let's start at the beginning. Okay, first we have to plot the vertex. The vertex was the point negative 2, 5, and we got that from the equation at the top. So we're going to plot the point negative 2, 5. And then we know that the axis of symmetry has to be where the vertex is. So the line x equals negative 2 is the axis of symmetry. Then we plugged in 2 points and we got 0, 4 and 2, 1. So if we graph those, we have 0, 4 and 2, 1. And because it's a parabola, it's symmetrical, so I can just reflect to this point on the other side, 2 spaces over, and this one is 4 spaces over, and there's my parabola. Pretty easy. So to do vertex form, you just look at the equation and you find the vertex first. We found the vertex to be the point -2, 5. And then you can plug in either 2 numbers on the left side or 2 numbers on the right side to figure out more points for your parabola. Okay, now let's look at an equation in intercept form. So we have y equals a times x minus p times x minus q. So p and q are your x-intercepts. So if you think about what that means, x-intercepts are the points where the graph crosses the x-axis. So if this was our graph, this is the x-axis, this is the y-axis, then if my parabola went like this, then these would be my x-intercepts, these 2 points right here where it crosses the x-axis. Now, notice the x-intercepts are p and q, but the formulas have negatives in them, so it's always opposite of what you think it would be. Okay, the axis of symmetry has to be halfway between the 2 x-intercepts. It has to be in the middle. So if I want to find the axis of symmetry, I can just find the point that's in between these two if it's easy. Or if it's not as easy, like I have fractions or something, then I can use the equation p plus q divided by 2. So if you take those 2 numbers, you add them together, and then you divide by 2, you can find the middle of those 2 numbers, kind of like finding the mean. Okay, now again, if a is positive, then the graph opens up. If a is negative, then the graph opens down. So we're going to practice. We're going to graph the equation y equals 2 times x plus 3 times x minus 1. So first we need to identify p and q. Now remember, because the formula is minus, we have to do the opposite. So it would actually be -3 and +1. So those would be our x-intercepts, not the vertex, but the intercepts. So those are the points where the graph crosses the x-axis at -3 and at +1. Okay, so we found the x-intercepts. Those are the points -3, 0, and 1, 0. Then we need to find the middle of those so that we can figure out our axis of symmetry and our vertex. So the middle of these points is going to be where the axis of symmetry is. So if I add these together, I can do the equation -3 plus 1 divided by 2. Well, that would equal -2 divided by 2, which would equal -1. So the line x equals -1 is the axis of symmetry. That's the middle of these 2 points. And that's also how I find the coordinates of the vertex. So if I know that the middle is at x equals -1, then I have to plug in -1 into my equation and figure out what point the vertex is. So I would have to plug in -1. So I have -1 plus 3, and then -1 minus 1. So this would be 2 times -1 plus 3 would be 2, and -1 minus 1 would be -2. So 2 times 2 would be 4. 4 times -2 would be -8. So the point, remember I plugged in -1, so the point -1, 8 is now my vertex. That's the middle of my 2 x-intercepts. So we're going to go down and graph these. So remember, at the beginning, we found our intercepts, -3 and +1. So we're going to go to -3 and +1. Those are our intercepts, okay? The axis of symmetry has to be in the middle of these 2 points, and you can find the middle, it's just 2 spaces over, or you can use the formula. So this would be the axis of symmetry. And then we found that the vertex, when we plugged in x equals -1, the vertex has to be somewhere on this line, and we found that it was at -8. And I think I forgot to put the negative sign on this one. So it was -1, -8, sorry. 1, 2, 3, 4, 5, 6, 7, 8. And then now I have points on both sides, so what I can do is just connect these, and there's my parabola. Pretty easy. Okay, lastly, we are going to be converting equations to standard form. So remember, let's think back. What is standard form? Well, standard form is just ax squared plus bx plus c. So we just have to have a regular old equation. Well, if I want to change from intercept form to standard form, what do you think the process would be? I have this equation right here. How do I get this to look like this? Well, I would think that you would have to multiply this out. So what we're going to do is use double distribution to work it out. Now I'm going to leave that 2 in the front alone because I find it's easier just to do at the end. So we have to double distribute, so we take the x times both numbers and the 5 times both numbers, and we're going to leave the 2 there. So x times x is x squared, x times negative 8 is negative 8x, 5 times x is 5x, 5 times negative 8 is negative 40. Okay, then I can combine like terms, so I get x squared, negative 8x plus 5x would be negative 3x, minus 40. Now I can distribute the 2 to all 3 numbers. So my final answer is 2x squared, and then 2 times negative 3x would be negative 6x, and 2 times negative 40 would be negative 80. So that would be the answer. And make sure you have the y in front still, because it is an equation. So we leave the y in front. So it's y equals 2x squared minus 6x minus 80. Now remember, vertex form has a squared in it in the equation. And we can still use the double distribution to work it out. But when I'm squaring something, what does that actually mean that I'm doing? Like if I take 4 squared, that means I'm taking 4 times itself, that number of times. So that means I have to actually write out, and this one has f of x in front, 4 times x minus 1 times itself, and then plus 9. So we're going to double distribute first, because remember you have to multiply first. So we're going to go ahead and distribute the x to both numbers and the negative 1 to both numbers. So then we get, leave the 4 in front for now. We have x times x would be x squared. Then x times negative 1 would be negative 1x. Then negative 1 times x would be negative 1x. And negative 1 times negative 1 would be positive 1. And then we have the plus 9 at the end. So if we combine like terms, leave the 4 in front, we have negative 1x minus 1x would be negative 2x. Okay, now we can go ahead and, do we add first or do we multiply first? If we follow the order of operations, we would multiply first. So we're going to distribute the 4. So we would get 4x squared, and then 4 times negative 2x would be negative 8x. And 4 times 1 would be 4, and then we have plus 9. So now we can combine the 4 and the 9 on the end there. So 4 plus 9 would be 13. And that would be our final answer. All right, don't forget to answer the essential question and write your summary.